Hello everyone, and welcome back to the Kohi game engine series. Today we are going to Jobify our loading of meshes and textures. So before we jump into the video, I would like to take a quick minute and thank the partners of the channel. The partners are the highest tier of support both on YouTube and Patreon, and they are Caden, Eearslya, Gerboles Inc., Super Awesome, and Wensheng. I'd also like to thank all the other fine folks that appear on the screen here. Your support is greatly appreciated. Thank you very much. If you'd like to support the channel and support my work, feel free to have a look at the YouTube membership, or if you prefer Patreon, you can check out patreon.com/TravisVroman. So last time we stood up our job system. We know that that's up and running as expected, and today we're going to make use of it. We are going to Jobify the process of loading our meshes and loading our textures. And we're also going to be adding a little bit more functionality to our meshes, because right now our meshes are basically just this structure, but there's no real logic surrounding them and so forth. So we're actually going to fill that out a little bit as well. So I think the first place that I want to start is patching a couple of things that I noticed are going to need patches. So I think before I do anything else, I'm going to go ahead and start with that. So the first thing I want to do is go to renderer types, INL. And in here we have our mesh packet data. And right now we have a mesh count with an array of meshes. We want to change that to an array of pointers to meshes. And the reason for that will be apparent once we make our changes to the application. The next thing we need to do is, because of this, we're going to have to go to our view and our UI. And we're going to have to make a small change to the C file in here. So within our build packet, we're going to need to make one small change. Right here where we are looping through the meshes, we're taking the address of the mesh data meshes. We're just not going to take the address anymore because now it's going to be a pointer. And we're going to do the same thing for the view world, where we are looping through here. We have our mesh here. Instead of taking the address of that, it is just going to be the mesh index itself, because it's going to be a pointer already. So that's just a couple minor adjustments there. In the Vulkan backend, we are going to make a minor change to apply instance. So let's see, right in here where we get the texture, let me just find it. So right here, we need to add a check to make sure that the texture is valid. And what I mean by that is we are going to check and make sure that the generation of that texture is not invalid ID. Because so far, when we've loaded up our textures, every texture has been loaded up before we actually start our render loop. So this would never have been the case. However, we're going to be loading in textures after we're already running at this point. And so we are going to have textures that aren't loaded yet, and so their generation is going to be invalid ID. I don't know why my other machine just started up in the background, but that seems fine. Okay, so anyway, so what we're going to do is we're going to check the texture map's use and say, okay, if it's a diffuse map and it has an invalid ID, we're going to get the default diffuse texture. Same for the specular and the normal map. And if we do not have one of those uses, we are going to fall back to the default texture, and we're going to warn about it just so that we're aware that it happened. This way that we have an actual texture that we can use that will be loaded and ready for us to use, because these default textures are loaded before we actually start our render loop. So we want to make sure that we have something valid there to always work with in case we run into a situation where our mesh is ready to render, but one of our textures within the material isn't quite yet. And that's going to be a fairly common scenario, so we need to handle that. The next thing that we need to do is go into our image loader. Image loader. And we need to make some adjustments to the way that this loader works. So the STB image by default uses the stdio library to load up the file and whatnot, but we already have file management stuff. We already have a file system that we can use to load that stuff up, and we don't actually need all that other stuff. So we are actually going to wind up using our own file system, and to do that we need to define one more thing, which is stbi no stdio, which tells the stb image library, we don't want to use your underlying system to load stuff. We're going to load the file and hand you the raw data instead. Another change we need to make is a little bit further down. So we have in our image loader load, we have this stbi set flip vertically on load. We need to switch this to the thread variant of that because we're going to be multi-threading this. So that's just a small change there. And then a little bit further down in our image loader load, right before our check here to see if we found something, we are going to take a copy of the full resource name and the name first. So we're actually going to move that to here. And then after we do this check, before these fields right here, we're actually going to use our file system to load up the raw texture data for us. So what we're going to do is we're going to open using a file read, and then we are going to get the file system size here. And of course, we're going to bleat about that if we are unable to find those things. And then instead of using stbi load, we are instead going to get rid of this actually. And right here, we are going to actually get rid of, actually we still do need that check. So right here, we are going to say an array of U8s, and we're going to call this raw data. And we're going to say allocate, and we're going to want the file size, right? And we're going to say memory tag texture. So this is just to hold the raw data for that. So we'll go ahead and change this data to raw data. And now we have a check here. Probably should update this this error message. We'll say unable to load file. Okay. Let's say read file. Actually, it's a little more accurate. And then here we need to put file system close, the address of F, which is our file, just to make sure that we close that out in the event that we are not able to allocate that memory for some reason. Okay. So the next thing we need is to go ahead and read all the bytes from that file. So right here, we're going to say bytes read is 0. We will pass the address of that here. So our file system read all bytes, we're going to pass the file handle, the raw data, which we allocated space for up here, and then the bytes read here to tell us that. And then we will go ahead and take that read result, make sure that it's successful, bleat about it if not, otherwise we will continue on. So we would have already closed the file here, so we don't need to worry about that. And then we're going to do a sanity check against the file read size versus the file size. So we have our bytes read here and a file size. If those things don't match for some reason, we are going to return false. Return that as a failure because that means that the file is most likely corrupt. The next thing that we're going to do is we are going to now load a data. And this is going to be a new array that's going to be created by the STB library. But instead of calling STBI load, we're going to say STBI load from memory. We're going to pass it the raw data, file size, width, height, channel count, and required channel count. So most of this is the same as before. It's just we're sort of loading from memory to memory here. And then, of course, we are going to have a check against that data to ensure that it is all good to go. If that fails, we'll go ahead and bleat about it and return false. Okay, so this is now done further up, so we can get rid of that. We can also get rid of this to-do because we are using an allocator underneath this kallocate, so we don't need that anymore. And then we're also going to get rid of the out resource name because we have already gotten that as well. So just a couple of updates there to our image editor, and that is ready to go. So that is now more or less thread safe. One more thing I want to do is go into loaderutils.c and adjust our resource unload. So right now we have this path length check, and we're basically looking at the resource full path. But there are possibilities where this full path may not be filled out if the resource load failed, and then we try to unload that resource or something like that. There are situations where that may not exist. So we are just going to want to wrap this logic in a check to make sure that it exists first, so that we don't get an error there. So we're going to just basically only free this memory if that actually exists. So that's just a small patch there. And let's see. So the next thing that we want to do is we actually want to go to our resource types. We need to make a small modification to our mesh structure. So right now we have a geometry count, an array of geometry pointers, and then a transform. We need to add one more thing, and this is for to basically make it work the same way as textures. We're going to have a U8 generation, okay? And that is just going to work exactly the same way as it works for textures. Basically, whenever we load the mesh, before we actually have content in it, it'll be invalid ID. And then once we have content in it, it'll be incremented. And every time it gets loaded after that, it'll also be incremented. So we'll have a way here to know whether or not the mesh has actually been loaded. All right, so that handles that. Before I jump any further into meshes, though, I do want to make some changes to our texture system as well. And I believe all these changes to the texture system are actually going to be internal. So I'm actually just going to go to the texture system C file. And the first thing I'm going to do is we're going to go all the way to the top, and we are going to add right here after a resource system, our job system, because this is what we're going to be jobifying. And we need a load parameter for this. So our load params are actually going to be a structure that we're going to provide. So let's see, after the reference is where we'll add this. And so this is basically going to take the resource name to be loaded, a pointer to the texture we're going to be loading to, a temporary texture to kind of write to in case we're reloading a texture, a current generation of the texture that happens to be if, again, we are reloading a texture, or as well as an image resource, right? And so this is all going to be passed in to the load parameters, okay? And incidentally, we are also going to use this as the result data from the job. So this won't be loaded right away, but it'll be loaded as a result of the job itself, okay? And then this is used, this same structures actually can be reused as the result data from the job itself. Okay, so the next thing that we're going to need to do is we're going to need to define some function pointers. So I think the very first one that we want to do is we'll come down here after our, we'll put it after our load cube textures, because most of these things are going to wind up being invoked by this load texture here. So this is what we're going to wind up jobifying. So we want a couple of callbacks here. The first thing that we're going to do is we are going to define our success callback. And the success callback is basically going to be once we've loaded the resource, we are going to call this method. So the first thing that we're going to have to do is we are going to have to take these parameters and do some casts against it. So we're going to extract the texture params from the parameters directly. This is that structure that we created further up here at the top. So it is here. So it's just that. And then our image resource data will have been what was loaded by the job itself we'll see in a second how that actually gets loaded. Now, I put a note in here that this load success, or this job success, is what actually handles the upload to the GPU. So the only portion of this that we're Jobifying at the moment is the portion that is loading the file from disk and reading that in and getting the raw texture data and processing it. So we're not actually uploading or Jobifying the GPU upload yet. We will come back and do that once the renderer is multi-threaded and has job support. So we don't have that yet, so right now we're going to just handle that in here. So what we're going to do is we're going to basically do what we did before, where we call our render texture create, passing in the raw pixels, and then outputting to our temporary texture. And we're going to take a copy of the existing texture. So that's going to be the params out texture that we had. We're just going to take a copy of that data. We are going to assign the temp texture to the pointer. So we're basically doing a switcheroo here. And then we are going to destroy the old texture. Okay, so this is where that happens. And then if the current generation of the texture params is invalid ID, then we're going to go ahead and set this to 0. If we were something else, then we're just going to basically increment that current generation by 1. So we'll go ahead and set that. And then we will go ahead and, just for debugability, for now we'll just output a trace message saying, hey, we've successfully loaded this. And then we're going to clean up the resource. So we're going to unload the resource itself. We'll go ahead and check to see if the resource name exists, get the length of that, use that to free that, and then go ahead and zero that out. Okay, so that is the success. The next one is going to be the fail, and the fail is not really going to do much of anything, so I'm just going to put the whole thing in here. This is basically going to look at our texture parameters and just spit out the name of the texture saying, hey, we failed to load this, and then unload the resource itself. So if it fails to load for any reason, this will just be where we get notified of that. The next thing that we're going to do is we're going to define the method for the job starting. And so this is what is actually going to happen when the job gets kicked off. This is going to be the job's on entry callback, essentially. And so what we're going to do first off is we're going to go ahead and take a cast of the load params. And then we're going to go ahead and set up some image load params. So this is our flip Y, basically what we're doing down here. And we're just basically moving a lot of this up into our job function here, but it's not 100% the same. So the next thing we'll do is we'll save off the result of the resource system load. So everything here is basically the same, except instead of immediately checking and returning false, we're going to store the result here. And what we'll do here is in resource data, we will get by just grabbing our load params image resource.data. So we'll go ahead and grab that. And then we're going to use a temporary texture to load into. So this is the temporary texture that we are sort of dealing with up here, right? So our temporary texture to load into, we just hit our load params, temp texture, we set the width, height, channel count. We set the current generation to the out textures generation, and then we set the out textures generation to invalid ID. This is to keep the texture from being used while we're actually loading up the new texture and trying to swap out the data on that. So as we're reloading a texture, there may be a frame or two where this generation is invalid ID, where it may, just use default textures on the screen. And that's to keep us from running into any issues with trying to use that texture while we're reloading it. So the next thing is we'll calculate the total size by getting the width times the height times the channel count. We're going to check for transparency, just like we've always done kind of before. And then next we'll also want to go ahead and take a copy of the name. And we'll want to set the temp textures generation to invalid ID as well. And then our load params, we're going to set the flags We're going to add, if it has transparency, we're going to add the transparency flag to that. Otherwise, we'll add nothing. And then we'll go ahead and copy our load params to our result data, which is the same exact size. So we can just do a one-to-one copy. And that will allow that to be stored in a location where we can safely access that once the job is complete. And then here is where we actually return the result. So we may wind up having to troubleshoot this a bit if we run into any failures along this. But this has been pretty stable from what I've seen so far. So here is, so that is basically our texture job start method. So our load texture actually becomes a heck of a lot simpler. So we can actually get rid of all of this stuff here. Don't need it. And this is actually the part that is going to be Jobified. So in this case, we're just going to fill out some info about our parameters, right? So our texture load params, the resource name is going to be basically a duplicate of the texture name that we pass in here. So that way we don't have to worry about the life cycle of that string. The out texture is going to be just this pointer that we pass in here saying this is what we're loading to. The image resource is going to be empty. The current generation is going to be the textures generation. And then the temp texture is also going to be just an empty texture for right now. Next, we will call our job create. So that's going to return to us a job info. And that's where we pass the texture load job start function, the success, the fail function, the address of the params, which will wind up having a copy of it made within the function, so we don't have to worry about the life cycle of this either. And then we take the size of the load params for both the success and the result, sorry, not the success and the result, but the on complete, on success and fail. Or I'm sorry, not enough caffeine today apparently. The parameter data size and the result data size is what I was trying to say. And that is it, right? So our load texture basically just fires off this job to load up the texture. And that is basically all we really need to do, okay? So this is actually Jobified now, which is great. So this can now handle our textures being loaded in a multi-threaded fashion. Okay, so the next update that we need to do is we actually need to create some stuff in resources for our mesh, right? Because we have something for our texture, but we don't really have anything for our mesh. We have a mesh loader in here, right? But we don't really have a mesh resource, as it were. And so under resources, I'm going to create a new file, and I'm going to call this mesh.h. And this is actually what's going to house our mesh's functions for right now. And this interface is actually pretty straightforward. So we have mesh load from resource, which just takes a resource name and a pointer to a mesh. And then we have an unload. So a load and an unload. The simplest interface you can possibly have. And that's it. That's all there is to that. So the mesh.c we'll go ahead and create. Mesh.c. And here we're going to have a series of includes. So mesh.h as expected. Then we have our k-memory, our logger, our job system, of course, because this is going to be Jobified. Our resource system, our geometry system, and our renderer types. So this, just like the images, is going to have a load parameter. So all this is a resource name, a pointer to the output mesh, and the mesh resource itself. And that's just going to be used for that. So just like we had in our for our textures, we are now also going to have a load success and fail and start for our meshes. So we are going to go ahead and define these things now. So just like before, we are going to cast our params to a known type. We are going to go ahead and take a look at our configs that are loaded in from our mesh resource data. And again, at this point, that will have already been handled. So we get the configs, we get the geometry count from that resource, and we get the geometries from that. So we just k-allocate an array for that. And then basically we loop through each one of those configs and acquire our geometry from the config that is passed here. And we go ahead and set that to geometries sub I. So basically just loop through those and create those from the configs. We also go ahead and we bump the generation on the out mesh just to make sure that that is incremented as it should be. And we output some trace info saying we successfully loaded the mesh, and we unload the resource. So this follows pretty much the same pattern as with our textures. Okay, so we have our job load success, we have our job load fail, and this basically just again casts the parameters, outputs an error, and then tries to unload the resource. So our job start is thankfully actually pretty simple this time around. So our job start, all it really needs to do is it needs to go ahead and get the casted parameters. And then once it has that, it will go ahead and call the resource system load for resource type mesh. So that's going to do all the heavy lifting for us. It's a nice, clean implementation in this case. And then we're going to go ahead and take a copy of the stuff that's in load params, and we're just going to load that into result data. So in this case, we only really care about the mesh resource. And then we're going to return the result. Okay? And that is it to Jobify meshes. It's really, really, really straightforward. And so the only things that we have left to implement are really our methods here. So I'm actually just going to copy these guys, come down here, turn these into function definitions. Okay. And our mesh load from resource is pretty straightforward. So it starts off by defaulting the generation to an invalid ID. And it goes ahead and creates some parameters and sets those things. So resource name, the out mesh to the out mesh here. And then the mesh resource to just an empty resource. And then we go ahead and we create our job just like we did before. So we just call our job create, pass our function pointers, our parameters, and then the size of our load params, which we're using for, again, the start and the complete. And then we just return true here, and that's it. That's all there is to loading meshes. Because we've already done this in our mesh loader, it's really simple to handle it here. The only other thing we have to do for our mesh unload is first off check to make sure we have a mesh. And then we need to go through each of the geometries in that mesh and just release them. And then we can go ahead and free the geometries array itself and go ahead and zero out the memory of the mesh. And then just for good measure, we're going to go ahead and zero out or set the generation to invalid ID, just in case that's from an array or something, so that we can free that slot to use elsewhere. And that is it in terms of our mesh implementation, right? So this is just a way to sort of get some of this logic out of the application and make it so that we can actually, just keep our application a little bit more simple. Okay, so second to last thing that we have to do is all of our updates to the application. So our application is mostly going to be just adding the resources mesh. So let's put that, I guess we could add it. Might help to have the right file open. I guess we'll put it in here, because we're not always going to need this in the application. We're adding a lot of stuff to this that eventually will be moved once we have scenes and stuff like that, but we don't have any of that yet. So resources mesh.h. Whoops. Mesh.h. Cool. So that's added there. All right, and our application state is going to need just a minor tweak. So what we're going to do is instead of having this mesh count here, we are going to have a mesh pointer for car mesh and a mesh pointer. Again, this is all temporary stuff anyways. Sponza mesh. Okay. And then we'll say B8 models loaded. Because what we're actually going to wind up doing is we are going to change, let's delete this as well. We're going to change the way that those two models load. And basically, we're going to load an empty scene with only the skybox in it at first. And then we're going to press a key to load in these other meshes. And that'll give it, it'll make it act a little bit more like a real engine would do, where you can just kind of load things in on demand. And then once we have triggered the loading process, we'll just flip this Boolean so that we can't do it more than once. Okay, so that is that. The next thing that we want to do is we need to change this event on Debug Event, because we actually need to add another Debug Event. So the first thing that I'm going to do is I'm going to surround this entire block with a check to say if it's event code 0, event code debug 0 rather, then we'll go ahead and do all of that. We're also going to check for something similar to this. We're going to be adding one. We're going to use debug 1 for this to load up our models for us, right? So we're going to check that flag that we just added to say if the models are not loaded. Then we're going to, first off, output some debug and flip that to true so that we can't do it more than once. And then we are going to call mesh load from resource for our Falcon and our Sponza. And we're going to do it here. And this will be done this way so that it's nice and dynamic, so that we basically can just do this on demand whenever we want. We can load up the scene and hit it immediately, or we can wait and hit it after a few seconds or what have you. So I think what I'm also going to do is if we hit either one of these, I'm going to return true here and return true here and return false here, because in this case we would not have handled that code. So we don't want to falsely report that we did handle it. Okay. So the next thing that we want to do is going to be in our application create. Probably right here, we're going to add a temporary debug just to set our models loaded to false. We'll obviously be removing that once we remove our test code. The next thing that we're going to want to do is a little bit further down where we're actually registering for events. We have our temp here for our debug 0. We want to register for the debug 1 event again. It's just going to use the same function because we're switching in there. We can do that. And then, let's see. I think what I'm going to do is down here at the very beginning, after we've stood up all of our stuff, so we have our world meshes. So we no longer have this this mesh count here. So I'm going to get rid of that. And instead, we're just going to step through and invalidate all meshes, right? So we're just going to set the generation on all those meshes to invalid ID. This is no longer going to use app state mesh count. We're just going to use a local one instead. So our cubes are still going to be loaded here. We're not going to load those dynamically, so I'm just going to remove this. We're also going to set our cube mesh generation, because we're using that now. We're going to set that to 0. This is going to not use the app state anymore. This doesn't use that. Our cube mesh 2 generation is going to be set to 0. And we have our app state. Going to get rid of that. Cube mesh 3 generation is set to 0. And we are now going to remove these two guys because we are not loading that geometry that way anymore. Okay. And I'm going to have to step away for a minute, so I will be right back. Okay, and I'm back. So, we've gone ahead and converted this to our new logic. So, the next thing that we're going to need to do is where we have deleted our car mesh and our Sponza mesh. We do need just a little bit of logic there. And again, this is temporary stuff. We are eventually going to be swapping all this stuff out once we have proper scene graph. But for now, all we're going to do is we are going to set the car mesh equal to the address of meshes at mesh count. And so we'll do that for car mesh. We'll set its transform to what it was before. We'll increment mesh count there. And then we'll wind up actually doing the exact same thing for the Sponza mesh. So these aren't loaded here. Generally speaking, you would want to set these things after they're loaded, or maybe have some sort of configuration to say, when you load it, set the transform to this. We don't have that yet. And so for now, we're just going to place the meshes here. And when they load, that's where they'll pop up. So again, this is very temporary code, but we'll be enhancing this as time continues. Okay, so one other thing that we need to do is, since our geometry now has generations, we need to come down here to our UI geometry, where we're sort of generating our little Kohi logo. And we're going to get rid of the UI mesh count because we don't have that anymore. And we're going to set the app state of UI meshes sub-0 to 0. So the generation of that is set to 0, so that way it is considered loaded at this point, because we're not going to feed that through our loaded pipeline. We're just going to not Jobify this and just do it here for now. Again, there's going to be a whole UI system that we're eventually going to drop in, and all this stuff will go away. It's just mainly to make sure that that layer is still working as expected. Okay. So the next thing that we'll need to do is go down to application run, down here, really where we have some of these errors. And what we're going to do is, first off, get rid of this check about the mesh count, because the mesh count doesn't exist anymore. And we'll go ahead and shift these over. And so we'll set the rotation on the first mesh. That's fine. We're also going to go ahead and set the rotation on the second mesh. If it exists, we know it exists at this point, so we're just going to go ahead and set that. Same for the third. We're going to go ahead and set that. And that way they always get set, because we know we're loading those in. Again, this is more of that test code, so it doesn't really matter if it's not necessarily the neatest at this point. Okay, so a little bit further down, when we are building our world packet, we actually need to make some adjustments to this. So we have the mesh data, mesh count, and meshes here. And so what we're going to do is actually we're going to delete these two lines, and instead we are going to come in here and create a temporary array. Oops. And we're just going to have a mesh count of 0, and then an array of mesh pointers that is 10 meshes long. And of course we're going to loop through our mesh meshes that we have in our app state. And this time we're going to look at the generation, and we're going to say, okay, if the generation is not an invalid ID, we'll go ahead and add it on to our array. So we'll have our mesh count here, which is this guy. He starts at 0. So it'll set it at mesh count index, and then we'll take the address of the mesh sub I. And then we'll go ahead and increment that mesh count. So it's basically a dynamic way for us to be able to only provide meshes to be rendered that are actually ready to be rendered. So again, we have a to-do in here to make this a flexible size array, and this is just temporary code. So for now, I'm not really too worried about it. And so we take those two things and we say, okay, our world mesh data mesh count is now mesh count, and our meshes is just this meshes array. And these things fit nicely into our packet, and we don't have to do this sort of dynamic allocation every single time. So our UI is going to be pretty much the same deal. It's going to be almost exactly the same code, so we're going to get rid of these guys. And we're going to say we have our UI mesh count and our UI meshes array. And just like before, we are going to loop through our UI meshes, look for anything that is not an invalid ID for its generation, add it to that list, increment the counter, and then set those things in the mesh data as normal. And that should be everything that we actually need to do for the application. So let me just go ahead and build this real quick, just to make sure I didn't miss anything. Might have missed something anyways, but we'll see. Okay, so there is one more thing, just a tiny thing that we need to do, because we said that we're basically going to load our meshes whenever we hit a key, which means we need to go to our game.c and add that logic in. And if you recall, we actually tied this to our event code debug1, and so we just need to put something in here to actually read that. So we're going to go down here to, I think the very end is probably the best place to do it, right inside of our temporary block here. And I'm actually just going to go ahead and put another temporary flag here. And we're going to say bind a key to load up some data, and we're going to use the L key for this, L for load. And we're going to say if it is up now and it previously was down, meaning we've released the key, go ahead and create an empty context, fire the debug1 event, and that will kick off our loading for us. So let's go ahead and build that. And we'll go ahead and run. All right. And I'll leave this sort of where it is for now. We can see that our cubes worked, so we at least know that that logic is working. And so what I'm going to do now is hit the L key, and we'll see that our Sponza mesh loaded in and our car mesh loaded in successfully. And this means that we were able to sort of multi-thread that load process and see that stuff come in a lot quicker than we did before. So these textures on this car are 4K textures. And so it actually takes STB image a little bit of time to process those. And so what I'm going to do is I'm actually going to exit the application. I'm going to load this up again. And the car is going to load up like somewhere here in the scene. And so I want you to sort of watch that section after I hit L. And you'll see that sort of the mesh pops up, and then the textures sort of pop up after that. And these cubes and stuff continue to animate, so it's all happening, sort of at the same time. So here we go. I'm going to press L, and we can see that right there. Those come in as they are loaded. So we know that we're running on multiple threads here. We're taking advantage of all of that. We see all of our job threads being assigned to. Here we're using, it looks like up to 10 of them. In fact, we're actually using all 15. So we have a lot of textures that are used by this Sponza mesh. So we're actually able to use all of our threads at once here, which is pretty awesome. And as you can see, it actually sped up the loading of the scene pretty dramatically. Now, you guys that have machines that don't have 15 cores obviously won't see quite as dramatic of a speed up, but even if you do have a machine that has, say, 4 cores in it, you're still going to see, that's almost a 4x improvement, right? And so just being able to do that is going to speed up things a lot. And so this is the first thing that we've Jobified. There's going to be lots of stuff that we're going to come back and Jobify later. But this is sort of our first dive into that. So with all that said, I'm going to go ahead and cut the video here. Thank you guys so much for following along and being here. I appreciate each and every one of you guys. If you like the series, you like the video, please toss me a thumbs up. It helps me out a lot. If you haven't subscribed already, consider doing so, because we are going to continue adding awesome features to this engine as we go, including a full-blown editor at some point. So anyways, thank you guys so much for watching, and I will see you guys in the next one.